Hello YouTube, this is Eric from Coder Snacks. Here's another live video with an NVIDIA interview question from Glassdoor. Write a function that, given two numbers and a range of bits, sets the ones from the first number into the second number in the range of bits given and changes no other bits. We'll use a full editor and REPL this time. As you watch this video, pretend that you're the interviewer. As I'm writing the code, watch for mistakes, things that you would comment on, and make a judgment about the code and what you'd want me to improve on as a candidate, for use improving your own skills. Let's get started. Hello everyone. So we have this lovely question where we're going to take a function that takes two numbers x and y and sets a bit range inside of it. This feels to me like a phone screen level sort of question. It's relatively simple, but it's all about bit manipulation and seeing whether you know the operations needed to construct a bit mask, what to get the correct bits out, and to set the correct bits in the target number. We'll give ourselves a pretty aggressive time target on this just to push us a little bit. We'll try to do this in 10 minutes. Let's see how we do. Here we go. So the idea is that we're going to have some pair of numbers. So the first one is x, which is the mask that we're going to set into the new one, and then y. The example we're given has this y on top and this x on bottom. And the idea is we want to take these 4-bit, or some number of bits, in this case these 4 number of bits out of x, and put them into y only if the ones are set. So, and not change anything about y else, right? So we're not going to change this one to 0. We're not going to change this one to 0. We're only going to change this to 1, and we're going to leave this as 1. So we need to split this into a couple parts. Get the correct parts out of x, put them into y. Okay. Let's write the function, and we're just going to call it set range and take in the x and y and n and m. So how do we get the correct parts out of x? What we need to do is we need to construct a bit string, or a mask, with all ones here and all zeros everywhere else. And what we'll do to do that, we know that we need some number of ones here. So we're going to use this trick where we say, take some number, put a 1 at the beginning of it, push it over the number of bits that we want the mask. So we end up with something like this, and then minus 1, which gives us this. And this problem, in terms of questions we might ask, in Python, the length of the number and so forth aren't important, but we might want to ask about things like handling negative numbers and so forth, which is much more difficult in Python. So if you're going to use Python to solve these kinds of questions, you need to be very familiar with it. We talk about this some in a past video, which I will link to. But let's assume for now that it's all positive numbers, or we can treat it as unsigned. So we know that we need to get a mask with m minus n plus 1 bits. So let's do that. Size of mask equals m minus n plus 1. Right. So in our example, it's 2 to 5, and we need 4. Right. Because it's inclusive, 2, 3, 4, 5. Okay. And we know that we're going to want that mask to start at n. So what we'll do first is we'll make the mask. We'll do this part of the mask where it's not shifted over. So mask equals 1 shifted over size of mask. And then we will shift the mask over the correct number. This is what it would be like if n were 0, 1, 2. So we're just going to shift it over n bits. Mask shifted over by n. Okay, so we have the mask. And what we want to do is we want to take x and get the part out that is correspondent with this mask, so that we're going to do an and there. So we're going to call this part to put in y. We could just modify mask to do this. It would be fine. I'm going to call it insertion part just to be a little clearer. So insertion part and equals mask and x. So now we should have zeros where there are no ones in the mask. The rest of it will be like what x is, and so this will be what insertion part is. Great. And then what we want to do is we want to take insertion part, and I'm going to copy y down here. We want to take insertion part and we want to OR it into y. So where it's 0, we don't want to change it, but 0 won't change anything with an OR. And where it's a 1, we want to put it into y. So we're going to say result equals y or insertion part. And we should be able to now return the result. And let's see that this works for the example that we've been given, right? So print, I think that if I say bin like 31, it'll give me what I want, right? Okay. Now this part here isn't going to have the leading 0, so we have to be aware of that. But print bin, so x is this 0, 1 sequence. Y is 4 zeros and 4 ones, 2, 5. And so this should give us 31. Let's see what we get. We get nothing. Bin takes exact right. Okay. So we want the bin of the function, not right. Okay, good. Set range. Good. Let's try it again. That's not what we wanted, or it's not what we expected anyway. So let's see. I'm going to print the bin of the insertion part and see, of the mask actually. And this is not at all what we wanted. And it's because I forgot to do the -1 on the mask. And now we get exactly what we want. Okay, good. Now we've got a few minutes left. Let's try to come up with some other interesting tests, just to see if there's anything else that we can break this with. So if n and m are the same, that just does something for 1 bit. Let's try that. So here we'll do it at, say, 3. And what we're going to do just to test that part of it is we're going to change x, the part that we're anding in, to all 1s. And we're going to change this to all 0s. And what this should do then is set only the 3rd bit, or the 4th bit, because it's 0 indexed. And that is what we get. And I'm going to take out this print now. Okay, so we did get that. What happens if n... So this would be a great error checking case. What if n and m, what if m is less than n? And we get, now this realistically should break, and it does. So we would want to either have some error checking here, or we would, and there are a few ways that we could handle that, right? We could swap them. Like if n is greater than m, we could swap n and m. We could return some sort of error. We could do a number of different things, which we would want to clarify with the interviewer. What other things could we test here? So if we have an x that is all 0s, then nothing should change, right? So if we have here all 0s, and this is all 0s, then we should get 0 back. except that I need to get rid of this test. And we do. And if we have another one where we say set a few, let's set this to an alternating pattern like that. Nothing should change. Right. Now, if we have one where these are all ones, it should become all ones, right? These zeros should just become all ones, and the one shouldn't change. So this should be all ones now. And it is. Okay. I'm fairly confident at this point that this is working correctly. I'm trying to think, and we've got 40 seconds left to think of more tests. We might try making some other tests that are less straightforward than this one, or than some of these. For example, if we set this to be, let's set an x where we have where we have all ones, but we're doing the part that's all zeros. So this is from bits 4 to 7. This should also be unchanged. And it is. And I'm going to put this up here to make it similar. So these two now are the same, which they should be. And if I change this to do bits 0 through 3, then we should end up with 1, 0, 1, 0, and then 1s for the rest of it. And I think time ran out, but that one works. So I'm fairly confident that this is correct, and I would be pretty good with this in an interview setting. There are a few parts of this that I think could be improved on, but we will leave that for the follow-on session, and we'll see you in just a moment. How did I do? Let's take a look at the code and my performance. Pause the video here if you want to make some final notes. As I said in the video, this is a simple problem as far as interview complexity goes. I would hope to move on after 10 to 15 minutes. The problem with this question is it only tests one thing, if the candidate knows bit manipulation. If this is a familiar topic for the candidate, it's quick, but if not, they will get stuck, which is another reason to only spend part of an interview on it. Overall, the coding for this was fine, although there are parts we will discuss cleaning up. The test cases were also reasonable, with a couple of gaps. I think this was a good performance, but there are several areas to improve upon. In my opinion, the biggest problem in this interview was not asking questions at the beginning. A couple possible questions we could have asked include, what should I do with invalid input? Say negative n and m, or if n is greater than m, or if n and m are greater than our number's bit length. Also, how should I handle negative inputs for x and y, especially in Python? We shouldn't jump to code immediately when we hear a problem. We should think about exactly what we want our code to do, what the user or interviewer wants, and what could go wrong. We should clarify these things, not jump in immediately. At NVIDIA, my guess is the candidate would be writing in C or Java, making some of these questions less useful. But in Python, we should consider some of these cases, and I didn't. Along the same lines, I didn't consider some of these things for test cases, and there are some small bugs in here because of it. Let's start with n and m. If n is far greater than m, we get an error as we expect. We could do several things, either automatically swap them, or raise an error, or return y unmodified, and so forth. But there's another possible bug here. What if n is just 1 greater than m? The code runs, and returns y unmodified. Why? When we construct the mask, we need to add 1 to mask size because n through m is inclusive. This means if we have n equals 1 and m equals 0, we get a mask length of 0, and 1 shift left 0 is valid. This mask becomes 0 afterwards. But how should we handle n greater than m? We gave 3 answers before, swap them, raise an error, return y unmodified, but in 2 of those cases, our code is doing the wrong thing. We should verify what the expected behavior is and modify our code. We alluded to this earlier, but there are other edge cases we could have tested. What if n and m are larger than the size of the ints? What if n or m is greater than the size of the n's? What if x and y are negative? What if n and m are negative? Additionally, we could test the boundaries around n and m better to check for off by 1 errors. There are some tests that handle this already, for example the all ones and all zeros test, but I could have been more explicit about it. Other than testing, I would have liked to see a little more time spent on cleaning up the code. This code is fine when developing. I think it makes a lot of sense to break things up and have more lines of code when you're focusing on getting the correct result. Afterwards, it should be cleaned up, made somewhat more compact and easy to understand and digest. For example, this part where I make the mask and I had an error because I forgot the -1, I could have had that be one line to begin with. I might not have had the error I fixed had I done that. There are a few other cleanups. We can get rid of this awkwardly named variable insertion part by combining those lines, and it's also a bit silly to calculate a result then immediately return it instead of just returning it. I think something like this is a good balance between readability and conciseness. I'm not saying to turn this into some ridiculous one-liner that would be faster to recode than to figure out, but doing some trimming like this lets us focus on what's really going on. I should have done some code cleanup. But overall, what is an interviewer looking for with this problem? Knowledge of bit manipulation, possibly some testing and engineering practices. I think this went well. The code overall does what we want, has some good tests, and went quickly. There are always areas to improve. Look for them in your own code, and practice and find areas to improve as you write more and more code. What's your opinion of my performance? Let me know in a comment. Next time, we're going to discuss linked list problems in interviews. There are a few questions about linked lists that get asked repeatedly, and we're going to do a whirlwind tour of 4 common ones. Think about some of them if you'd like, but your time might be better spent visiting a site such as Glassdoor, HackerRank, or UVA Online Judge and practicing a problem that looks interesting to you. I hope you found this video useful. If you have any questions, comments, things I've missed, or problems you want answered or covered, let me know in the comment section below. And if you enjoyed this video and want to see more, it would be great if you liked the video, subscribed, or both. I really appreciate it. See you here next time on Coder Snacks.